this one, I'm going to start the same way I always do. I'm going to draw a line down the center, turn everything into sines and cosines, and simplify. On the left-hand side, I notice that I have two sets of parentheses. So what I'm going to do is I'm going to FOIL. So if you'll remember foiling, multiply the firsts together. So 1 sine x and 1 minus sine x is what I'm really doing in the background. This becomes 1 plus sine x minus sine x minus sine squared x. And if you'll notice, these cancel, so this side becomes 1 minus sine squared x. Now that should look very familiar. I'm going to change to a different color and write off to the side. If you'll remember, sine squared x plus cosine squared x equals 1. And I notice that I have 1 minus sine squared x, and I can get 1 minus sine squared x here if I subtract sine squared from both sides. So this gives me that cosine squared x is 1 minus sine squared x. And that is a perfectly valid trig identity. So instead of 1 minus sine squared x, I can turn the left-hand side into cosine squared x because they are equivalent. So the left-hand side will be cosine squared x. On the right-hand side, there are actually two trig identities you could use. I could either say, hey, I recognize secant. So this is going to be 1 over, and then secant is 1 over cosine. Still squared. Or you could recognize that this is cosine squared. I do not care which method you do. If you do this, if you will notice, I can do 1 over 1, flip and multiply, and I will get the same answer. And so this is also simplified. And I will notice that I am done because my left-hand side matches my right.